7.6 absolute value functions and transformations. With these functions, we are given an absolute value function in the order of slope-intercept form practically, and we are plugging in values for x, solving and graphing. So if we look at example A, we have g of x is equal to the absolute value of x plus 3 minus 5. So we're going to plug in these x values. So we're going to have the absolute value of negative 6 plus 3 minus 5, which is the absolute value of negative 3 plus 5, which is equal to 3 plus 5, which is 8. Now, I don't know why I just changed that to a positive or a plus, but we are actually going to subtract this 5 from the 3, which will give us negative 2. That looks better. Now, we have the absolute value of negative 3 plus 3, which is the absolute value of 0. 0 minus 5 is negative 5. For the negative 1, we have the absolute value of negative 1 plus 3, which is 2, minus 5. 2 minus 5 is negative 3, so it's negative 3. From here, 0 plus 3 is 3. The absolute value of 3 is 3. 3 minus 5 is negative 2. The absolute value of 1 plus 3 is the absolute value of 4. 4 minus 5 is negative 1. The absolute value of 3 plus 3 is the absolute value of 6. 6 minus 5 is 1. And the absolute value of 6 plus 3 is the absolute value of 9, which is 9. 9 minus 5 is 4. So these are giving us the ordered pairs of negative 6, negative 2. Oops. Negative 6, negative 2 is here. Then we have negative 3, negative 5. From there we have 0, negative 2. Then 1, negative 1. Then we have negative 1, negative 3 we didn't graph, which is here. And then we have 3, 1, and 6, 4. So we draw our line through these points. Now, any absolute value function will give you a V on your coordinate plane. For example B, we have g of x is equal to the absolute value of x minus 4 plus 2. So we're going to plug these values in once again. So we have the absolute value of negative 5 minus 4, which is negative 9. Negative 9, the absolute value of that is positive 9, plus 2 is 11. The absolute value of negative 3 minus 4 is the absolute value of negative 7, which is 7. 7 plus 2 is 9. The absolute value of negative 1 minus 4 is the absolute value of negative 5, which is positive 5. 5 plus 2 is 7. The absolute value of 0 minus 4 is negative 4. That's positive 4. Plus 2 is 6. The absolute value of 1 minus 4 is the absolute value of negative 3, which is 3. Plus 2 is 5. The absolute value of 3 minus 4 is the absolute value of negative 1. That's positive 1 plus 2 is 3. The absolute value of 5 minus 4 is 1. Plus 2 is 3. So when we go to graph these, we have negative 5, 11, which is 1, 2, 3, 4 here. Then we have negative 3, 9, which is here. Next is negative 1, 7, then 0, 6, 1, 5, 3, 3, and then 5, 3. So the way that this is, our slope looks like we are going to have a point at 4, 2 as well. We could plug that value in and solve if you wanted to, or you can just eyeball it practically. Oops. Let's try to get this straight. It's as straight as I can get. Okay. If we look at our next example, we have g of x is equal to the absolute value of x plus 1 plus 2. So this one doesn't give us our x values. I'm going to choose to do, let's say, -5, -3, -1, 0, 1, 3, and 5. It's totally up to you which ones you use. So for the -5, we're going to have the absolute value of -5 plus 1, which is the absolute value of -4. That's +4 plus 2 is going to give us 6. For the 3, we have the absolute value of -3 plus 1, which is the absolute value of -2, which is 2, plus 2 is 4. Next is the absolute value of 1 plus 1, which is 0, plus 2 is 2. The absolute of 0 plus 1 is 1, plus 2 is 3. The absolute value of 1 plus 1 is 2, plus 2 is 4. The absolute value of 3 plus 1 is 4, plus 2 is 6. And the absolute value of 5 plus 1 is 6, plus 2 is 8. So graphing these ordered pairs, we are first going to do -5, 6. 1, 2, 3, 4. Right here. Then we have -3, 4, which is here. And then -1, 2, which is there. We have 0, 3, which is here. 1, 4, and then 3, 6, and lastly 5, 8. So we draw our line through those points. And then we're done. For the constructing functions from graphs that are given to you, with these, your red line is just f of x is equal to the absolute value of x. Now, this would be literally this function here. So we want to know how it's moving or how it's changing. This is just going up 2 and to the left 1, or sorry, to the right 1. So there's going to be two types of transformations here. Anything that's going to the right or left is going to go inside the absolute value bars with x, and we're going to use the opposite sign to represent it. Anything that's going up or down goes after the absolute value bars and either added to or subtracted to. So because we're going to the right 1, or sorry, we're going to the right 2, this is going to be the absolute value of x minus 2. And then because we go up 3, that's going to be plus 3 outside the absolute value bar. So that's just going to be f of x is equal to x, the absolute value of x minus 2 plus 3. For b, once again, we would start at the origin and go this way. So how is it moving? It's going to the right 1, so it's going to be the absolute value of x minus 1, and then it goes up 3, so that's plus 3. And then set it equal to f of x. For c, we're going left 2 and up 1, so that's going to be the absolute value of x plus 2 minus, or plus 1 outside. When we have stretches or compressions, we are either getting larger or smaller based off of the way these lines are separated from one another. So if we look at example 3a, we have g of x is equal to 2 times the absolute value of x. So we're going to pick x values, plug them in. I'm going to use -2, -1, 0, 1, and 2. And see what these give me. So this is going to be 2 times the absolute value of -2, which is 2 times 2, that's 4. 2 times the absolute value of -1, which is 2 times 1, that's 2. 2 times the absolute value of 0 is 0. 2 times the absolute value of positive 1 is 2. And 2 times the absolute value of 2 is 4. So we're going to graph these on our coordinate plane. We have -2, 4, which is here. -1, 2 is here. 0, 0, 1, 2, and 2, 4. For b, we have 1/4 times the absolute value of x. So I'm going to pick numbers that are going to give me whole numbers here. So my x values, I'm going to use -8, -4, 0, +4, and +8. So I'm going to have 1/4 times the absolute value of -8, which is 1/4 times 8. That's going to give me 2. 1/4 times the absolute value of -4 is going to be 1. 1/4 times the absolute value of 0 is 0. 1/4 times the absolute value of +4 is 1. And 1/4 times the absolute value of 8 is 2. So plot these points. -8, 2 is here. -4, 1 is here. 0, 0, +4, 1, and 8, 2. So draw your line through those points. And then you're done. For C, we have g of x is equal to 3/5 times the absolute value of x. So again, I'm going to choose values that are going to give me whole numbers here for x. So I can use 10, 5, 0, 5, and +10, -10, -5. So this is going to be 3/5 times the absolute value of -10, which is 3/5 times 10. That's going to be 6. 3/5 times the absolute value of -5. That's going to be 3. 3/5 times the absolute value of 0 is 0. 3/5 times the absolute value of 5 is 3. And 3/5 times the absolute value of 10 is 6. So plot these points. We have -10, 6. 1, 2, 3, 4, 5, 6. Then we have -5, 3. 1, 2, 3. 0, 0. 5, +3. And 10, +6. So we draw our line through those points. And then we're done. Reflecting with these absolute value equations, if it's in front of the x or in front of the absolute value, you're reflecting across the x-axis. If it's inside the absolute value, you're reflecting across the y-axis. So again, we can pick ordered pairs, plug them in. So for A, we have g of x is equal to a negative times the absolute value of x. So I'm going to pick -2, -1, 0, 1, and 2. So now the negative absolute value of -2, that's going to be -2. The negative absolute value of -1 is -1. The negative absolute value of 0 is just 0. The negative absolute value of 1 is -1. The negative absolute value of 2 is -2. So we plot these points. -2, -2 is here. -1, -1 is here. 0, 0, 1, -1, and 2, -2. For B, we have g of x is equal to a -1/2 absolute value of x. So again, I'm going to pick values that are going to give me whole numbers. So I can pick something like -4, -2, 0, +2, and +4. So it's going to be a -1/2 times the absolute value of -4. -1/2 times 4 is -2. -1/2 times the absolute value of -2 is -1. -1/2 times the absolute value of 0 is 0. -1/2 times the absolute value of 2 is 1. And -1. And -1/2 times the absolute value of 4 is -2. So we plot these points. -4, -2, -2, -1, 0, 0, 1, -2, and 4, -2. Oh, this should be 2, -1. I'm sorry. This is 2, -1. That looks a lot better. For C, we have g of x is equal to a -4 times the absolute value of x. So again, just picking x values that will work. I'm going to do ones like -2, -1, 0, 1, and 2. So I plug these in. -4 times the absolute value of -2 is 8. -8, I'm sorry. -4 times the absolute value of -1 is -4. -4 times the absolute value of 0 is 0. -4 times the absolute value of +1 is negative 4. Negative 4 times the absolute value of 2 is negative 8. So plotting these on our coordinate plane. Negative 2, negative 8 is going to be here. Then we have negative 1, negative 4, 0, 0, 1, negative 4, and 2, negative 8.